Established 40 years ago, PSC is an aviation engineering organization equipped with aircraft, subassemblies, and avionics components manufacturing and MRO services, encompassing the product ranging from primary flight trainer aircraft Mashak and Super Mashak to modern multi-role jet fighter JF-17 Thunder aircraft, along with aero engines and airborne avionics. The engineering setup is equipped with modern, state-of-the-art machines and established processes certified by International Aerospace Quality Standard AS 9100 Revision C, ISO 9001-2000, Boeing Quality Management System and NADCAP, etc., to name a few. Precision machining, sheet metal work, composite and rubber parts manufacturing, special processes, surface and heat treatment facilities are the strategic business units of the organization. PSC values its customers and believes in working closely by extending cost-effective engineering solutions through highly skilled human resources and advanced engineering processes at the most economical cost. Aircraft Rebuild Factory was established in the early 70s in collaboration with the People's Republic of China. Initially, the factory started overhauling of F-6 aircraft, and with an ever-growing sphere of responsibility, the factory undertook the task of overhauling of A-53, FD-5, Y-12, K-8 and F-7 aircraft variants. Since its inception, ARF has evolved into a center of excellence for maintenance, repair and overhauling Chinese aircraft, standing tall amongst MRO organizations in the world. The MRO setup has a number of accreditations to its acclaim, which guarantee quality production. The MRO setup is not only fulfilling the needs of Pakistan Air Force, but also undertakes overhauling and repair tasks of friendly countries, namely Sri Lanka, Zimbabwe, Nigeria, etc. The core facility has a rich experience of manufacturing and overhauling canopies and windshields of Chinese T-37, Cessna, IL-78 and Mirage windshield partitions. It has also acquired the technology for manufacturing single-piece windshield. The competency is completely self-reliant and has ensured zero foreign dependency. Production Support Group at ARF is a hub of metal parts manufacturing with diversified services like CNC and conventional machining centers, forging and casting, surface treatment, and NADCAP qualified heat treatment facility. Precision Machining Complex is a Boeing Quality Management System certified CNC setup capable of manufacturing aviation and military standard aluminum, steel and titanium alloy parts by using the latest CAD/CAM software. The products are qualified by utilizing the state-of-the-art coordinate measuring machine. PMC is manufacturing parts for Chinese origin fighter and Boeing 777 aircraft. Drop tank manufacturing facility is capable of fabricating supersonic tanks along with repair and testing of metal tanks for modern fighter aircraft. It features a wide array of sheet metal processing and welding facilities along with expertise in argon arc, seam, spot and electric welding processes. Stringent stage-wise quality control ensures achieving highest of the aviation standards. ARF has progressively ventured into commercialization and acquisition of modern technologies. Establishment of C-130 propeller overhaul facility is a recent success story in this field. It has been established in collaboration with Derco Aerospace and is certified by Hamilton Sundstrand. The facility has broad capability spectrum and is fully conversant with latest aviation technologies. Other than overhaul of C-130 propellers, it is also carrying out repair, fabrication, rework and overhaul of its accessories including the pump and valve housing. With addition of quick engine change overhaul, it has become the state-of-the-art facility that is being offered to friendly countries as well. Harness Manufacturing and Rework Center manufactures and repairs wiring harnesses of various types of aircraft. The capability spectrum includes a wide variety of harnesses. A harness is a complex combination of wires and connectors. This task is very delicate and requires high skill levels. Elaborate testing of all the manufactured and repaired harnesses is carried out. The work center is qualified for rewiring of used aircraft with new harnesses. Equipped with laser marking, thermal transfer printing, and automated testing facilities, this work center provides all modern technologies under one roof. Metrological Center ARF is one of the leading calibration and testing facility in defense sector of Pakistan for calibration of PMEs and testing of aviation and general industry parts. It is an ISO 17025 accredited laboratory. Capabilities of this work center include physical, chemical, metallographic and non-destructive testing. Besides calibration of PMEs related to length, pressure, mass, volume, force, temperature and frequency. The standard equipment used here has international traceability for its accurate functioning. It extends calibration and testing services not only to PSE and Pakistan Air Force, but also to various reputed public and private sector Pakistani and foreign organizations. Mirage Rebuild Factory was conceived in 1974 for in-country overhauling of Mirage aircraft and has ever since evolved into a center of excellence for maintenance, repair and overhaul of military aircraft and jet engines. It is duly certified by Dassault Aviation of France. The process begins with the complete disassembly of the aircraft. The parts, components and accessories removed from the aircraft are routed to specialized setups for complete strip-up, stringent inspections and comprehensive repairs as per the overhaul manuals. During the process, the components that can be repaired undergo extensive repair procedures. In case the parts cannot be repaired through any of the repair schemes, they are replaced to ensure perfect health of the aircraft. After the assembly, the operation of each component is verified by extensive testing. The operation of these components is simulated on specially designed testers. These testers replicate close to actual operating conditions which these components experience on a flying aircraft. Results of testing achieved on these components are strictly monitored and it is ensured that the achieved results are within the prescribed limit set by the manufacturer. The highly precise components requiring overhauling in dust-free environment are overhauled in a special facility. Atmosphere in this facility is cleaned continuously to achieve the required air cleanliness standards. The overhauling of aircraft is never complete without repairing and replacing the worn-out hydraulic and fuel pipes. MRF has established a 5-axis CNC-controlled pipe bending and fabrication facility capable of automatically modeling and manufacturing all aircraft hydraulic or fuel pipes. The modeling software interprets model of pipe. The fabrication module uses the interpreted design to prepare new pipes of required dimensions and angles from straight lengths of pipes. To achieve self-reliance, MRF embarked upon the uphill task of establishing the all-encompassing setup for overhauling of engines of Mirage aircraft. Duly certified by SNECMA of France, the engine overhaul setup has become the backbone of Mirage fleet operations of Pakistan Air Force. Like the Mirage aircraft, the Atar engine is also stripped down to individual components. All components undergo a thorough cleaning process to remove the contaminants accumulated during the flight on aircraft. The cleaned parts undergo non-destructive inspections to identify the existing defects. Highly specialized radiographic inspection techniques identify even the minutest cracks existing in the parts. The radiographic machine is equipped with a robotic arm to position the part for accurate identification of subsurface cracks. An elaborate setup of specialist NDI techniques is available for identifying the microscopic imperfections in aircraft and engine parts. Non-destructive inspections are also aided by a semi-automated eddy current inspection machine. The machine runs its probes on the predefined geometry of the part and identify the existing defects. Use of the automated probes eliminate the chances of human error. Crack identification on the ferrous parts is also carried out by a state-of-the-art magnetic particle inspection machine to identify the subsurface cracks. Over a span of more than 30 years, MRF has inducted numerous state-of-the-art technologies for maintenance and manufacturing of aviation parts. High-velocity, oxy-fuel and plasma coating techniques are used for seamless build-up the parts that wear out during the operation of the jet engines. Parts reclaimed by these techniques are given a new life and they get ready to be installed on the engines for the next span of their operation on the engine. Pakistan National Accreditation Council and ISO 17025 certified precision measuring equipment laboratory is providing calibration services to keep the overhaul equipment ready to make precise measurements. Overhauling the engine accessories is a vital support setup required for successful overhaul of any jet engine. Meeting up to the requirement, MRF has set up an elaborate system for overhauling the accessories. The process begins with completely stripping up the accessory to the basic components. The components undergo a series of elaborate cleaning and inspection steps, and the defective components are identified. As per the nature of defects, either the components are repaired or replaced, and then the accessories are finally assembled. The final step of overhaul is comprehensive testing of the accessories. On the last leg of its overhaul journey, the engine is tested on the multi-engine test cell. The test cell is capable of testing various types of overhauled engines from idle to their maximum thrust in afterburner settings. Closed-circuit cameras enable monitoring of engines with highest accuracy to determine minutest flaws or fuel leaks to ensure highest levels of reliability. The test cell control room gives complete controlling and monitoring capability to the technicians running the engine. The technicians operate the engine on virtually every part setting and check all the critical operation parameters. After satisfying all the required standards, the engine is declared fit for installation on a fighter jet. The capability of the Mirage Rebuild Factory has been enhanced over the years to overhaul the engines of other military fighter and transport aircraft. In the same pursuit, a Rolls-Royce certified facility has been established for overhauling the T-56 engine of C-130 aircraft. A continuous endeavor to enhance capabilities has led to establishment of a state-of-the-art aviation overhauling facility for TFE-731 Honeywell engine of K-8 aircraft. After thorough ground studies, the first TFE-731 engine has been inducted in MRF for overhaul. In 1989, realizing the requirement of PAF to maintain newly inducted F-16 aircraft, MRF assumed the huge undertaking of establishing the overhauling setup for F-100 engines of F-16 aircraft. Pratt & Whitney's certified overhaul facility not only looks after all modules of F-100 engine, but also upgrades 200 type engines to more powerful 220E type engine, and has upgraded the entire F-100 engines fleet of Pakistan Air Force. The ISO 9001-2008 Revision C compliant elaborate setup of quality control and assurance programs monitor the overhaul process for any possible deviations. The outsourcing of Boeing parts manufacturing to MRF is a testimony of the professional appeal MRF enjoys. Over the years, MRF has become a blend of state-of-the-art facilities, outfitted to embark upon aviation-related MRO requirements from anywhere, whether local or abroad. Self-reliance, professionalism, and commitment remain the sole guiding inspirations for MRF. Aircraft Manufacturing Factory was established in 1975 to undertake manufacturing of a primary flying trainer aircraft under license from Saab Scania of Sweden. The aircraft was named Mashak, meaning proficient, and was produced from the kits provided by Saab. After successfully producing 92 Mashak aircraft, AMF acquired the status of Original Equipment Manufacturer or OEM in 1981. Within a short span of just 30 years, AMF has produced more than 300 Mashak aircraft, which are successfully flying not only in Pakistan but also in foreign countries such as Saudi Arabia, Oman, and South Africa. The Mashak not only meets the requisites of international aviation standards but also conforms to Pakistan and South African civil aviation standards. And that is why it is the frontline aviation product of Pakistan. During the course of manufacturing, AMF, in order to improve the design and performance, produced an upgraded version of aircraft in shape of Super Mashak. Equipped with Lycoming 260 horsepower engine, advanced avionics package, Garmin and Dynon glass cockpit, and side-by-side seating for instructor and student pilot, Super Mashak forms an ideal platform for a variety of roles. Short takeoff and landing distance, higher G-load bracket, excellent stall and spin recovery, and above all, excellent after-sales spare and structural spare support are some of the key features rendering Super Mashak aircraft to be far superior than its contemporary primary flying trainer aircraft of the same class. The aviation industry in Pakistan has experienced a tremendous growth in last 30 years. Over the years, AMF's stature as aircraft manufacturer grew manifold, with successive capability achievement to manufacture jet aircraft trainer K-8 in late 80s, unmanned aerial vehicle Falco in 2008, and the modern jet fighter aircraft named JF-17 Thunder. Today, Aircraft Manufacturing Factory has the capability of manufacturing structural parts and aerostructure assemblies such as the horizontal stabilizer, elevator, vertical stabilizer, rudder, and front fuselage of K-8 aircraft. Keeping abreast the evolving trends in aviation, AMF decided to venture in manufacturing of unmanned aerial vehicles through the latest carbon composite material processes. Pakistan Air Force, after a comprehensive operational and technical evaluation process, decided for establishment of Falco UAV manufacturing facility at AMF. During the first phase, 8 Falco UAVs were received in form of semi-assembled kits. The final assembly and system integration of these UAVs was successfully accomplished at AMF PSC Kamra under the supervision of OEM in 2007-8 timeframe. During the same time period, state-of-the-art equipment was also purchased to start co-production activities. After commissioning of the equipment and training on parts manufacturing, the newly established manufacturing facility was qualified by OEM to manufacture Falco UAVs on European quality standards. An aviation industry is considered at its pinnacle when it has the capability of manufacturing a modern fighter aircraft. Today, AMF has complete infrastructure, core capabilities, and state-of-the-art technologies for manufacturing of JF-17 aircraft. Machining Center for Production of Aircraft Parts is equipped with state-of-the-art conventional and CNC machines. Parts with relatively lesser accuracies are manufactured on conventional machines, whereas complex parts involving higher accuracies and profiles described by higher-order polynomials are manufactured utilizing the CNC machines, integrated with computer-aided design and computer-aided manufacturing systems. Sheet Metal Workshop for JF-17 parts houses an array of conventional and CNC machining facilities. Machines such as guillotine and nibbling shear, conventional and CNC stack routers, etc. are utilized for processes like shearing, routing, and sawing techniques, whereas CNC short peen forming, hydraulic quintus, fluid cell press, CNC stretch forming, and CNC punching, etc. are used for manufacturing of parts involving sheet forming processes. Pipe manufacturing, emerging recently as a separate technology of manufacturing, caters for the requirements of aircraft hydraulic, pneumatic, and oxygen systems. It involves pipe bending, end fitting, testing, marking, and covering. The most typical equipment being used in pipe manufacturing is CNC pipe bending machine. Special processes form an integral element of any modern manufacturing facility, as almost all sheet metal and machine parts undergo heat treatment, surface treatment, welding, and various other types of special processes during manufacturing. Vacuum oil quenching furnaces, air circulating and conventional furnaces, etc. are employed for heat treatment, whereas chemical treatment facilities include anodizing, chromating, bluing, phosphating, pickling passivation, electroplating, primer painting, and chemical milling, etc. Every manufactured part has to undergo a series of testing and inspection procedure from raw material till final stage at Material Testing Center. Material Testing Center has the capability to conduct all kinds of physical, chemical, and non-destructive testing of materials, including testing capabilities of all heat and surface treatment equipment for periodic qualification. The first phase of aircraft assembling starts at Aerostructural Build-Up Facility. Hundreds of sheet metal and machine parts, pipes, and components, etc. are skillfully put together with the help of thousands of rivets to build aircraft subassemblies such as fuselage, wings, horizontal and vertical stabilizers, and ailerons, etc. The aircraft starts to take shape at final assembly setup, where subassemblies, all system parts, engine, piping, cabling are installed and integrated before sending the assembled aircraft to flight test station for stringent power on and functional checks of each and every system of the aircraft. This is followed by a series of aircraft ground runs and quality shakedowns before finally handing over it to the test pilot for yet another series of functional check flights to ascertain the airworthiness. The manufacturing of JF-17 Thunder fighter at Aircraft Manufacturing Factory has brought Pakistan amongst select group of countries of aviation world. Attainment of this capability in less than a quarter of a century itself speaks of the highest standards of dedication that AMF engineers and technicians showed since the word go. Avionics setup of Pakistan Aeronautical Complex, known as Avionics Production Factory, was initially established as the Radar Maintenance Center in 1983 for overhaul and rebuild of ground-based radar systems. In 1989, it was transformed into a full-fledged avionics factory with ability to handle avionics as well. Today, this factory, with its state-of-the-art facilities, can undertake production of different types of avionics as well as commercial electronics equipment while ensuring high-quality standards as per the requirement of Aerospace Standard 9100C. The factory has produced numerous avionics systems like Grifo 7 and KLJ-7 airborne radars, radar warning receivers, identification of friend or foe systems, digital, audio, video and crash recorders, various mission computers and navigation systems. Most of these systems have been co-produced in collaboration with Chinese and Western manufacturers. The factory has also produced various commercial products such as PSE pad called Takhti 7, PSE notebook and e-book reader. The avionics production facility at APF can be divided into 6 major segments: design and development, avionics integration, production line, testing line, specific system department, and environmental stress screening facilities. APF can undertake design and development of avionics systems based on user requirements and provide complete solutions from concept to life cycle maintenance of the products. The prototype avionics systems are designed using computer-aided design and simulation tools. The prototype systems also undergo electromagnetic interference and electromagnetic compatibility and environmental qualification. Systems developed at APF have qualified and are flying on fighter aircraft. The developed system prototypes are functionally tested and integrated in the Dynamic Simulation and Integration Laboratory known as DSI. The facility can also undertake integration of off-the-shelf systems with an avionics suite. Being a certified avionics integrator with years of experience, APF has developed core integration technology for meeting requirements of new fighter aircraft and upgrades and modifications as well as retrofits in older aircraft. The systems are validated through hardware in the loop ground testing in simulated environment and are subjected to flight trials before final qualification. After successful qualification, serial production is undertaken utilizing semi-automated and automated machines. APF is a qualified production vendor for various companies, and its generic production line employs stuffing of surface-mounted and through-hole electronic components on bare printed circuit boards. PCB stuffing is a multi-stage process involving PCB inspection, cleaning, and drying before these are ready for components installation. The processed bare boards are then passed through automated assembly line which installs the components. Few components like connectors, etc. are however installed manually. The assembly line is configured to adapt to production of any types of PCBs. The completed PCBs are inspected using optical and X-ray inspection systems for faults before being passed for testing. The standard of workmanship during complete production process conforms to requirements of IPC 600 and 610D standard. Stuffed PCBs are passed to generic testing line for in-circuit and functional testing. These PCBs are powered on and tested to ensure serviceability of individual components and complete functioning of PCBs. The testers are adapted for testing any electronic assembly. The testing facility is generic and comprises of sophisticated test stations. APF has the expertise to develop complete testing solutions, including development of software programs and mechanical adaptations for testing. When PCBs have been stuffed with components and tested, these undergo conformal coating before being fed to specific system department. Here, these sharp repairable units, along with other components, electrical and mechanical wiring, and harness assemblies are put together as a line replaceable unit for final testing of system. Since the processes require unique procedures for each system, there are separate assembly and testing areas for every system. Once a system is ready, it is passed over for environmental stress screening, where these systems are exposed to practical military environment with the help of thermal climatic chambers and shakers. The aim of this strenuous testing is to ensure that the equipment conforms to actual aircraft environment as per requirement of Military Standard 810D. The systems that pass through this process are guaranteed to perform reliably when put into operation. Avionics Production Factory also provides life cycle maintenance for these airborne avionics systems. Factory employs skilled manpower with years of experience in repairs. The facilities are equipped with latest test and measurement equipment, and repairs are undertaken as per international quality standards to ensure original equipment manufacturer specifications. APF also carries out overhauling and refurbishment of low-level and high-level ground-based radars, especially Mobile Pulse Doppler Radar known as MPDR. The facilities available with APF are electronics modules repairs and testing, cable and harness repair and manufacturing, which includes RF, signaling and power cables, antenna structural repair and testing, troubleshooting and repair of hydraulic systems, gear testing facility, and radar vehicle overhauling. Overhauling of radars give a new life to the old radars and are considered fit for operations for another life of 8 to 10 years. The factory has so far overhauled more than 90 MPDRs and TPS series of radars. APF has come a long way to acquire the knowledge and skill in the field of quality production and repair of avionics equipment and overhaul of ground-based radars, and looks forward to enhance this capability further to achieve the excellence.